welcome back. We're going to chug out a smart contract today. I know I say that and maybe it'll end up being an hour. I hope not. We're going to try to write it as quickly as possible. While we will be using the card game contract from the first course from the official Elemental Battles tutorial later, when we learn DApp network services and a variety of other things, I want a simpler contract for us to work with when we're using Scatter, learning other wallets, learning a number of other like deployment and things like that, a more lightweight contract. So as a refresher, maybe if you haven't written a contract in a while, or if you're a genius who knows C++ and has never written a smart contract, but you can just like absorb knowledge, we're gonna chug through a simple smart contract today. Now this is more preparation for advanced tools than an advanced tool itself, but we are gonna be using EOS Studio, and EOS Studio really has made some definite strides since last time. There's now a cloud option, a cloud net. You can log in and have projects on the cloud. There's a scatter integration. There's key management, key pairs. You can upload your keys to the cloud if you're doing development keys. There's a test button with all kinds of cool stuff going on. You can pick different versions of EOS.js and just overall impressive work. Sadly, it doesn't have all the features we need for later. We're going to be using Zeus SDK and potentially another IDE in the future. But for now, this is great. Let's create a new contract instead. So create project, local project. I'm going to go ahead and plant it right in that EOS ABDT folder that I've created for these things. That seems to not have done anything, which is less than encouraging. It's possibly because I don't have disk access with the new Mac OS. So let me quickly go into System Preferences, Security, and make sure that we do indeed have disk access enabled for EOS Studio. Mailing list 4, it was successfully created. Open that and call the project mailing list 4, go. All right, we created a new project. There's a readmd .md file that just says this is an example, blah, blah, blah. And wow, this is a much more significant example than before, which is great. But we don't want all this stuff, so we'll just update it. We've got our header file and our main C++ file, which will have the user-facing actions. And what I want to do, I'm going to actually create a new file here called Pseudocode. And what we want to do is create a mailing list contract with two actions. Users can register. We'll call that maybe something like reg user, right? And if the user is already registered, then it throws an error, right? It says you've already registered. Otherwise, I'm using non-standard spacing here. Richard Hendricks would really kill me. Otherwise, register the user, right? Add them to the table of users. And likewise for unregister, which we'll call unreg user, I could just go ahead and copy all this. If the user is not registered, then say, you're not even registered. Why are you trying to unregister? Otherwise, unregister the user. So I'm just going to need one table called maybe mailing list, and it's going to just have users, and the primary key, I'm actually coding here in the pseudocode, right? The primary key is going to be username.value. So the table is going to only contain usernames, and it's going to be keyed to those usernames because you're going to want to be able to easily look up users by their name. And since in EOS, usernames are actually a representation of a 64-bit integer, and you can get that 64-bit integer with this .value here. Because of that, we can do something like this. So this is our struct right here. I already created it. I'm going to go up to mailing list or mailing list header file, and that is our main table. And then we've got our type def, and I'm going to do this EOSIO. The reason being we are going to have DApp multi-index tables later. and we need to keep it clear that we're using an EOSIO multi-index table. We'll call it mailing list. It uses the mailing list struct that I've just created. The actual name is mailing list table. So the name in the blockchain, the name in the ABI, the name in state is going to be mailing list. It's based on this struct. The table is a macro that reduces to struct called mailing list. And we're actually calling this mailing list table as a type. So now our actions are going to be register user. And that's going to take just a name, username, and unregister user, which also takes a name, username. Apart from our constructor, we're good. Now, can I remember how to do the full constructor? Let's see, we need a receiver, and then we need code, and then we need a data stream, and it's something like this. Yeah. And then contract, we give it the same, we give it these things we just made. And then the actual mailing list table will go here. I'm using like Larimer spacing for my parentheses here. I don't know if that's Larimer spacing anymore, but all right, receiver and receiver.value, right? Something like that looks right. I've written about 100 of these, but I wouldn't be surprised if it's like, nope, error. You can't, this is not correct. We're not even using standard, so forget that. Not using strings here. Okay, well they're using strings in the default, that's why. So we have an action username, or sorry, register user. And it takes username. I'm just gonna get rid of all this. This is the kind of thing I want to write from scratch. Okay. Register user, unregister user. We're just creating a quick contract in order to learn other technologies. So let's see, this user, we need to get the user's authentication, right? Authorization. And then we need to see if user is already in table. And then assuming they're not, we need to add the user to table. All right, and then we have our unreg user action, which will basically, if they are and if they are not here. Okay. All right. So now I'm going to take this little pseudocode and turn it into real code. So we've got require auth for the user. The user is the only one who can authorize that they are going to register or unregister. I really can't type on camera, guys. Sorry about that. I need to create an iterator that's going to look through the mailing list table. It's going to try to find, and the primary key is username.value. So if the iterator comes up empty, then it will be an end state. Okay? And so if it's in end state, all right, so we didn't find them, then we add the user to table here. All right? Else, this really isn't the way to do this. I'm going to actually do an EOSIO check. I'm going to check to make sure that the iterator has reached end state. And if it hasn't, then I'm going to say, you have already registered. Okay? And so otherwise, I'm going to add the user to the table. So EOS check, like the old EOSIO assert, it makes sure that the first thing is true. If it's not true, then it ends execution and it throws this error back. The action never hits the blockchain. It doesn't take up any resources or anything. All right. Otherwise, we add the user to the table. So we're going to, in our mailing list table, in place a new record with the username, and we got to do our little lambda function here, which is like very prone to typos. So of course it's going to be the only thing I get correct this whole video. All right. That should add them. So we've emplaced a new record using this lambda function in our mailing list table. Obviously, we have to end this this parenthesis here, like that. All right, so that should do it for reg user. Now we need to delete users otherwise. We can use a lot of the same material here, which means that I should abstract it out into another function. It really does. And I'm tempted, very tempted to do that right now. I might do it in a second. Unexpected type name mailing list. Expected expression. Oh my gosh. Of course. I completely forgot to declare. Oh my gosh. All right. I completely forgot to declare this. All right. That should do it for us. Now we've got 4 errors. Where? What the heck? I don't have the... Oh, wait a minute. Really? No. What do you want from me? Oh my gosh. All right. I'm so dumb. So very, very dumb. I wasn't including these functions in the class. Mailing list 4. Mailing list 4. Because they're in a separate file, I have to do that. All right, so now hopefully we will compile. 4 errors generated. That's actually more errors. I have more errors than before. Which is not what I wanted. All right, no viable conversion from name to you. Okay, of course, we need to find username.value whenever we find. We don't just find username, because the primary key in these tables is not the username, it's the value of the username. It's the 64-bit integer that's behind the username. Now we have 7 errors generated, so that's just great. No matching function for call to check. Well, yeah, that's because this parenthesis does not belong here. It belongs here. I was getting the wrong number of arguments. 5 errors. Okay, 5 is better than 7. All right, we expect an unqualified ID. Mailing list dot delete. Is it erase? You know what? It's erase. Well, my constructor, that's dumb. My constructor I accidentally put in the private section. That's no good. Public, please. Privacy is overrated. 4 errors left. It doesn't like erase, in place, all this stuff, find. So what is wrong with my table? Every single time I ask it to do something like this, it says, no, I'm not going to do that. Oh gosh, of course, I'm missing a keyword here. Keyword return. Like, my function to give you the primary key, it wasn't actually returning the key, so the keys didn't work at all. And it's just simple, forgetful things like that that make you, make your contract not work. We have successfully built this smart contract. So with those human error things, syntax things implemented, this is why testing is so important, because the bugs you don't miss, you don't find from compiler errors. With those addressed, we now have a finished contract that registers a user, requires their authorization and adds them, or unregisters, requires and deletes. And in the add user, we find a user and we make sure that they don't exist. Right? If we're adding them and they already exist, we tell them so. And in the delete user, we find them and we make sure that they do exist. because if they don't exist, then there's no need for them to unregister and we end execution there. Otherwise, we erase them and we're good to go. So that's built. Let's deploy it just locally for now. I'm going to turn on my local network, start it up. Looking good, looking good, looking good. EOSIO is going. Let's create a local account called mailing list 4. Create. All right, successfully created. And now let's deploy. We'll switch to that account. And we will crash EOS Studio. Well, I've had a wonderful time. I hope you have too. Let's quit and start it up again. Spin up our local network. Thankfully, the account's already selected here. Nodeo stopped. What? Why? Ah, it's dirty, isn't it? It's dirty. All right, so let's go in and make sure we replay all blocks. Or no. Just clear it out completely. Delete all blocks. All right, start it up now. All right, let's deploy this contract to mailing list 4 account. Deploy failed. You don't have signatures. Oh, I deleted all blocks, duh. Oh, great, so now I have to create the account again. And we're gonna crash EOS Studio again, aren't we? Create. All right, insanity is repeating something and thinking that you'll get a different result. But in this case, it paid off because developers are insane. Right, so I'm gonna deploy mailing list 4 to decisions, like the guy with the space soldier, the astronaut or whatever with the button. All right, select. All right, we've successfully deployed the contract. Let's take a look at it now. Mailing list 4. All right, we can register user and unregister user. Let's register ourselves. We're going to register mailing list 4 to our contract. Go. Internal service error. You are already registered. Even though I'm clearly not registered, I suspect that I got these falses and trues backwards. I did. I got those backwards. All right, let's rebuild. See, on Ethereum, that might have crippled us. Project over because of missing not sign. It wouldn't be the first time, I'm sure. And now we're going to go back to our contract and try to register again with user mailing list 4, register. Success. And you see that mailing list 4 is in the users table. Now we're ready to send spam to mailing list 4. So let's try to unregister the user. Actually, let's try to register again. Mailing list 4. It says error, you are already registered. That's true. Now let's try to unregister mailing list 4. Succeeded, and yes, mailing list 4 is in fact deleted. Now let's try to unregister them again. Now what we expect is the error saying you're not even registered. Yes, you are not in the mailing list. All right, so our contract works. We're gonna register again. So now we've built this contract in order to connect to EOS wallets. We want someone who has an EOS wallet to be able to add themselves to the mailing list, to be able to remove themselves from the mailing list. That's the only purpose we built it for. We will also use it to explore test deployments to test nets and things later. We have a simple contract that works, that has some simple functionality. It's not overly complicated or weighty. And we'll get started next time with connecting it to EOS wallets so that users can use their wallets to interact with our smart contract.